How do you hear me? Fine? Anyone hear me? Okay, so I have a very short talk. It was supposed to be, like, originally this talk is 50 minutes, so it's almost an hour talk. And now I have 10 minutes. And I was like, you know, what do I do about it when I realized, because I realized that after I have submitted my talk. And I was, okay, so maybe, you know, I should try just, you know, talk 5 times faster and then, you know, go over with it. But then I realized that it's probably not going to work. And instead, what I did is I chose like 3 things that I think I should, like, that I think would be like most useful of that talk. And then afterwards, like when I came in here, I realized that like probably I should condense my talk even more. And so, but unfortunately, I couldn't really edit my slides anymore. So I'm going to skip over some slides like completely. Just ignore that, and I'll explain, you know, a couple of things, well, 3 things that I think are, well, really interesting to know. And like, because you're monitoring guys, I don't know how is that going to be for you, because database guys who work with databases, they usually find this very interesting and surprising. And actually, I had like a few customers in Percona who were just, you know, driving me crazy with that. They were like, no, this cannot be truth. So, you know, let's talk about it. Okay, so the second thing that I'm going to talk about is load average. The third thing that I'm going to talk is disk I/O, but I'm not going to talk like everything about disk I/O. And I was going to, but then I realized that there's one, like if there's one thing that I want to convey about disk I/O, then, you know, that's it. And well, you're probably wondering what's the first thing, right? So the first thing is, it's kind of a mantra that we have in Percona. And it was like one of the first phrases that I heard from our CEO, Peter Zaitsev, when I was just starting, like 8 years ago when I started at Percona. Like almost any problem that customer was facing was, you know, approached in that mantra, which was, you know, don't worry about it, it's just a system, you know, we'll figure it out. And it's actually like, it's an idea that if you like want to, you know, solve some kind of a problem, you just have to understand how everything works out. Like if it's somewhere on the high level, you have to know, you know, have to have some kind of a X-ray vision, how we call it, which is understand every single element that's, you know, going down to the where the, you know, the root cause of the problem is. So you know, just think about it, because it's like the key thing in looking at it this way is to really understand the very, very basics of, you know, how systems work. And a couple of other things that I'm going to talk about are also really, really basics, but sometimes people don't get them right, and that actually confuses everything. So the thing is that when you have this, you know, attitude of looking at everything as a system, you actually can apply, and especially like when it comes to computer systems, right? You can apply this knowledge to pretty much any system, and that's, you know, that's why, like, you know, even though like we mostly work with Linux, we can apply this systems knowledge to pretty much anything. We just have to, you know, realize how the tools that we're using, for example, for inspecting those systems are working on those different systems. Now, the second thing, like I said, is going to be load average. Now, can anyone tell me what does load average of 1.0 mean on a system? Yeah, there's a volunteer right there.
So it's one process waiting.
Yeah, okay, so it's, well, it could be one process waiting, it could be, well, yeah, it's basically, it's doing something on the system, right? It could be waiting on I/O, or it could be waiting on CPU. But, so, the thing is that load average, and I think this is where most of the confusion comes in, is that load average isn't really a utilization metric, you know, that you can use to understand how busy your system is. Rather, it is a metric of how many processes on your system are, you know, busy, waiting, or doing something. I have a quick quiz then, with that in mind. Well, imagine there's a server, and actually there's an actual server, because I'm going to show you one benchmark that I've done on that server, so keep in mind the specs. So it has two 6-core CPUs, so 12 cores all in all, with hyper-threading off. It has 32 gigs of RAM and 8 disks in RAID 10 array. Now the question, which load average would indicate that the server is saturated, hence the server is busy? So let's just vote, okay? Who says it's A? Answer A. Answer B? Answer C? Answer D? And answer E? Okay, so actually the answer seems to be kind of simple, because like those who either raised their hands like every time or none of the times were actually correct, or who said like it depends. Because and let me get to this, because actually either of those could mean that the server is saturated, that it can no longer accept any more work without queuing it. So in case of 4.0, as you remember, it's a RAID 10 with 8 disks. So it means that it has 4 bearing disks for writes. So that means that if you have 4 writing processes and they're all waiting for, well, basically actively writing to disks, then load average of 4.0 would mean that the server is actually saturated and it needs to queue up work. So it's, of course, it's like 4.0, it's kind of like idealistic, right? It's not going to be 4.0, it's going to increase eventually if you give it more work. In case of 8.0, it could be 8 processes reading from disks. And I assume that nothing else is happening on the system. It's just doing that thing. So in case of 12, right, so if we have 12 processes using CPU, then load average of 12.0 would indicate that the server is actually saturated. And if you add more work, it's going to the load is going to increase, but you start to queue up tasks. 16.0, it could be like 12 processes on CPU and 4 writing to disks, and then 12 on CPU and 8 reading from disks in case of load average 12. So, but like I said, the key thing is that it's not like load average is not something that you use to understand how utilized your server is. It's just something that what is my server doing? If you see load average increases, and sometimes, especially with databases, it's really a good thing, like that load average is increasing, and that's where customers get frustrated the most. Like we come to them. We have like, let's say, load average of 1.0 or 2.0, and it's like, we have a problem. There's something wrong with the database, and load average is, is crazy. It's 2.0, right? And then we fix something, right? Let's say we upgrade MySQL to the one that has less contention, and it's actually able to do more work right now. And the load average increases. It's like 8 all of a sudden. And the customer, why? What did you do? You broke our server. Like, let's go back. And I'm, no. It's doing more work now. Can you see that everything works faster all of a sudden? Well, yeah, I see it. But load average, it's, what did you do? Let's go back. So I find it really hard and for people to explain that, well, sometimes it's good that you have load average. It means that your server is utilizing your server better. So, just something to have in mind, that load average and high load average isn't necessarily bad. It means that your server is doing work, so that's a good thing. Disks. So now is the slides that I'm going to skip over really quickly, so don't worry about it. Yeah, and this is the part that I want to explain. And that's pretty much the last slide, but I want to really be attentive just so we can get this right. So what I'm doing here, and in case you're not familiar, this is PT Disk Stats. It's one of the Percona Toolkit tools, which, like many didn't know, are free, just like any other software that we make, like Percona Server, XRDB Cluster, everything else. So what I'm doing here is actually on the same RAID that I mentioned, which is 8 disks in RAID 10 array. Those are 15K disks, not SSD. Those are 15K disks. So as you probably know, one 15K disk can do 250 I/O operations per second, random I/O operations per second. And what I'm doing here is I'm running a benchmark which completely saturates, well, it's just like pushing disk to the limit at a certain concurrency. This is important. Now, at this point, well, you can see concurrency here. Like what concurrency? So it's 1.0. That means that the benchmark that I'm running, it's only using one thread at one time to do read operations. This is how many read operations per second you are getting at the moment. It's basically maxing out that disk, right? And this is the read size. It's not as important in this case. This is how many megabytes per second you get as a throughput. Then this is the read response time. So how many milliseconds does it take to do the read? And now this is what I want to focus on. It shows like how busy the disk is. And many people who use like either disk stats or PT disk stats or IOStat, they would see this, well, in IOStats it's util column. It says like 100% busy, and they're like, oh no, my disks are completely saturated. And I want to show you how this is completely not true. I hope I can explain to you why not. Let me try to do that, but it's just completely, like this metric is actually completely meaningless unless you're running a system with just one disk. On one disk system, 100, like the percentage here actually means how busy it is. And so, okay, so what this number shows is really like during the, well, second in this case, because it's sampling every second, how, it's measuring how long does it take for response to get back from the server. And based on that, like it calculates how busy it thinks the system, the disk was. So in this case, it shows 100% busy because it was like trying to do as many I/O operations as possible, and it could do this many I/O operations. And all in all, it divides basically 1 second by the number of I/O operations, and it gets this response time, and it sees that there's no way it could do any more I/Os as it's running single-threaded. So one might think, okay, so the system is like disks are completely busy. Now I increase the number of requests, or rather I increase the concurrency to 2. So basically I now do twice more I/O requests. So you see, even though it seemed like my disk was completely saturated, it showed 100% here. Actually, if I double the concurrency, now I can do twice as many I/O operations per second. So 100%, seriously. Now let's go even further. I'm going now to increase the concurrency basically logarithmically, and it's going to be a lot of information, but let's just go over it line by line maybe. So in this case, the concurrency is 4.0, and it's still actually doing like even twice more than it did just before, right? And as it progresses, you can see that this array is actually capable much more than what we started from, right? So we started with 250, almost 250 operations per second. It showed that it was 100% busy, but it was like completely not true because we could increase the number of operations basically 20 times since where we started. Like the 20 times is because it's, well, actually I think it's picking up more reads like on the single revolution because it's rather small data set that I was working on. And now, so how do you understand really how overloaded your disks are, right? If you can't really use that. The way we usually do this is we want to understand like what's the latency that you would normally expect from your disks, right? So that's something you either know because on rotating disks, you can basically calculate that very simply. So you know how many revolutions per second your disk is doing. Per minute is usually, right? So 15K disks, they do 15,000 revolutions per second. And so you basically divide 15,000 by 60, and you get the number of operations per second. So so 15K can do 250, and well, let's say, if we take and 7.2K disk, it's usually about 100 operations per second, a little bit more than that. If you use SSD, and this is important, like single SSD drive, from this perspective, is in a way like a RAID, because it can actually access the data with multiple threads. So you probably, if you have a benchmarked an SSD, you may have noticed, like, just a single disk, that if you benchmark it at concurrency of 1, you could get like 1,000 operations, 2,000 operations per second. But if you increase concurrency, you will actually get more operations per second. So this is the cool part of the SSD. But when it comes to measuring how loaded your SSD is, you hit the same problem. So while with spinning disks, you would only have that problem with multiple disks, right? With SSD, even if you have just one SSD drive, you have to look at the response time to understand how busy the disk really is. And so what you can see here is that, well, response time of about 4 milliseconds is what you could normally expect from that disk. So, if you see that, it means that, well, it's busy, but, probably if I add more I/O requests, it's still going to be fine. And we can see it's true, because if we double the number of requests, it's still serving them in about 4 seconds. If we add more, well, for a little bit more than that. And when we actually go to concurrency of 8, which is, pretty much how many concurrent I/O requests it can do, because it's an 8-disk RAID 10. So this is where it starts to back up a little bit. It's getting to 6 seconds, then 6 milliseconds, sorry, then 7, and then eventually it becomes really much slower. Does that make sense? Okay. And actually, that's pretty much it. Like, during this talk, I usually get a question, because it's inspecting, Linux, machines. I get questions like, okay, so what tools do you use? Like, and people would normally start to list all of those, D-stats, B-stats, V-stats, L-stats, and whatever they're using for monitoring. And I think that it doesn't matter really what tools you're using. The key thing is understanding how the tools that you are using are actually representing the real information that they're getting from your server. And the tool that I use most is VMstat. The good thing about VMstat is that it's there on every system. So, whichever customer system I log into, I have VMstat. And it has most important information for me. I'm not going to go over it right now, because I think I'm running out of time. But it really represents, well, how busy my system is, and just by looking at that, I understand whether I have a problem or not. Of course, I have to know like how many CPUs I have on the system, how many disks, and then what kind of a disks, so I know how many reads, writes, for example, it can do. So I start with the VMstat, then I go to disk stats if I see that there's many blocked processes. And if I see, many processes here, I would maybe use mpstat. But it really, the key thing, like I mentioned, is really just to understand how the tools you're using are representing what's happening on the system. And remember that it's just a system. Yeah. So, any questions? No? I'm glad. Well, hopefully that means that either you understood what I said and you agree, or you want more. Okay, thank you very much.
Yeah. Thank you, Aurimas.